Hi, today I'm going to walk through how to do the temperature corrections step by step. Okay, so today we're going to do the morning of June 15th. So this is the AirBeam file that you get straight from the sensor. Open that bad boy up. You might get something like this. I'm using a program called LibreOffice. Um, I'm sure most of you are going to be using Excel, but everything I do in here should be exact or mostly the same in Excel, and it should work just fine. Um, so on to a couple little setup things we want to do. First, we want to delete the first 8 rows. If you notice on these files, the first 8 rows are kind of like information on these columns. Okay, like this one's, sensor package. This is column F is the temperature. This one is particulate matter, but we don't need these for the corrections. So select the first 8 rows, right click on them, and go to delete rows. That'll make things a lot easier down the line. Okay. Second step, if your timestamp isn't showing, you just gotta open that up. There we go. Because we're gonna need to be able to see these timestamps. Second thing, click one of the cells with data in it, and you want to, on your keyboard, you want to hold down Control, Shift, and down arrow. I'm gonna have to put the phone down real quick because I don't have a tripod, so bear with me. Alrighty, Control, Shift, down, and that's left control, because that matters. Right control won't select. So what this does is selects all the data up until the very end of the data series, which today happens to be 5,389. And these are per second, so that's how many how many seconds were recorded. So we want to select the cell just after that, or actually the row just after that, and do the same thing, Control Shift down. Okay, what this does is it selects all the rows up into the like the theoretical maximum that Excel can do, which happens to be like 1,048,000. Okay, so right click this, go to hide rows. Boom. Okay, now they're hidden. Now we just have the data series. We kind of trimmed out the file. This is going to be very important because later on we're going to be selecting empty columns and doing the Control Shift down trick again. And if you do that without doing this first step, it'll select everything from number 2 all the way down to 1 million, and that'll just ruin the performance. It'll make saving take like 10 minutes. Every time you do something, it'll take like 10 minutes because it has to calculate 1 million entries instead of 5,000, which is what we want to do. Okay, so now that we've cleaned that up, you want to go to column F. This is our temperature. You see here, this is the morning, so 78 degrees, a little warm, not too bad. Not like the afternoon, which I'm sure you are all aware of. So select F and go to insert columns after. Then I'll insert a blank column. Do this 5 times. 1, 2, 3, let me look at the screen and not the phone. 4, 5. Okay, now we got our 5 columns. Okay, the first time you do this, you're gonna have to type it yourself. I have the luxury of already having a pre-done thing, so let me just go ahead and copy and paste. Oh yeah, Control C. After you select cells, you click Control C, and that copies all the highlighted data. And then we want to select these empty ones. Control V will paste and that, and then these are just our labels where we're going to put things in: Kestrel temp, Kestrel curve, AB curve, corrected temp, daily average. Okay, these are the 5 columns you're going to have to need to make yourself. Alrighty. Next step is we got to do the tedious task of getting the times. This is my Kestrel data. Every group's gonna have or maybe even every person gonna have their own way of doing this. This is kind of just how I set it up. Just pretty simple. Locations, the time, the exact time, and then the temperature, all the Kestrel stuff. And I just put it in a simple Excel file, which makes analyzing things easier. It takes a lot of time, but it's well worth it. Also for the time, it doesn't matter right now because it's the morning, but like for the afternoon and evening, you're gonna want to do these in a 24-hour format. So like if it's 2 o'clock, you want to like 2:10, you want to put 12:10, and it's easy just for just add 12 to whatever time you have, and that gives you the 24-hour time because the sensor here records things in 24-hour time. Can't really see it now because it's the morning, so 8 and our time is the same as 8 and 24 hours. But if this was the afternoon, these would be hour 14, not hour 2 at PM. Okay, so we got our time. Our first Kestrel point is going to be 78.8. I'm going to Control C, and then go back here. I'm going to go Control F, and that brings up the find dialog, and I want to search for that time. So 08 colon 110. Click enter. And that should find the first instance of time 8 hour 8 minute 10. Okay, so we want to put that, let me look at the screen, put that on column G, which is our Kestrel column, and then Control V, the temperature. Okay, great. You want to do this 12 times. Okay, I'm not going to do that on camera. So I'm just going to copy and paste this column from the already did one, and Control V here, and overwrite that. Spare us all the tedium of watching me do that. Okay, cool. Now that you got all 12 data points entered in here, you want to go to Insert Chart. This is kind of where it begins to differ from LibreOffice to Excel, but I'm sure at this point you all know how to create charts based on columns, and if you don't, there's plenty of resources. I know Professor Will Cole has a PowerPoint, and then your group mates probably also know. Anyways, you want to get a scatter plot, and then get a little preview. Make sure it's kind of like a rational thing, like it makes sense. So this is within the expected temperature values, and make your little plot. Cool. This is all your Kestrel data. You want to right click on one of them, insert trend line, and then you want to click polynomial degree 2. You want to show equation, show coefficient of determination, and click OK. And then you want to kind of drag that out so it's like some kind of readable area. And this will give you, this is the mathematical best fit line for this particular set of data. It's going to be a parabola because it's degree 2 for all you, for all my math girlies out there. And then this is the equation describing that line. This is how we're going to generate a whole not continuous, but a whole field of data points. Okay, so let's just move that out of there. Go back to the top, and then we're gonna have to enter this formula into cell 2 underneath Kestrel curve. So to do that, you select this little enter, field right here. You go equals, and then we go down here and we write the first few digits of this. I don't think we need that much because the final, this data is only 2 significant digits, so we only need a few digits for that. So 5.182, yeah, four digits is fine. And then the exponent, which is very important. If you don't do the exponent, it makes things wrong. In order to do that, this is scientific notation or engineering notation, whatever. You do E for exponent, and then see this is negative 0.7, so negative 0.7. So that's just 5.182 times 10 to the negative 7. Very small number because this is going to be a very, smushed parabola. Okay, now for the x squared component. The x values we're plotting against are these object IDs, and conveniently they're all, counting numbers 1 through 5,000. So you want to do asterisk, which is that star sign. That's called an asterisk. And then object x starts at column A, row 2. So we're gonna do A2 right here. So this is this number times A2, and because it's x squared, we got to do that again. So times it by A2 again. Cool. Now we got the x squared part, and now we just got to do the rest of this. I think in Excel it kind of defaults to just a few digits. You might not see as many digits as I do, which you'll probably really happy about. 0, oops, not 9. 0. Oh shucks, A2 minus 0.001115. Okay, that's the first few digits of this one times x, and if you remember, yes, that's right, A2. So times A2, and then finally the final coefficient plus 76.52. Okay, cool. Now we've taken this formula and put it into the second cell of column H, and then this will tell Excel to auto-generate a point for us. Cool, that's great, that's wonderful. We got one down. Now, using the power of automation, we can Control C to copy this cell, and then Control Shift down arrow to select all the cells. I'm going to put the phone down real quick. Control Shift down, and that selects everything from row 2 down to row 5,389. If you didn't do that first step where we hid the rows, you would go all the way down to 1 million, which would be terrible. Anyways, now that we've got all these selected, Control V to paste, and look, now the computer automatically calculated all the little points in between the 12 original Kestrel points. Great. Isn't that lovely? Okay, we want to do this whole curve thing again on column F, which is the sensor sensor temperature things, temperature points. Do a scatter plot again. Cool. And we just want to do the exact same thing we just did. Polynomial 2. So equation, show coefficient determination. Move that to somewhere you can see, and then move this off to the side. And then I'm going to copy and paste this one because it's the exact same data. But yeah, oops, wait, no, I copied and pasted the wrong one. Oh, live. Don't you just love watching a boomer do something like this? Okay, Control V, okay. We got our equation in there. You're going to be typing this out by hand. I have the convenience of having already done this. Control C, Control Shift down, Control V to paste everything in. And there we go. Back to the top. There we go. Now, finally, the correct attempt. This is what everything's been leading up to. For this, let me bring up. We want to type in something. If you did the columns the same as I did, then you can type this exactly as shown. What this is doing is it's an if statement. It's checking column F, which is the sensor temperature data. And if column F has a blank, like, because sometimes the sensors don't always record a temperature for every second. Sometimes it has blanks. And if there is a blank, it's going to put a -100. And that way there won't be any like discontinuity. I mean, there won't be any like blank cells, and any blank cells will have a very large negative number, which we can all ignore. And if not, if there is data there, we're going to take F2, which is the sensor measurement, plus H2, which is our Kestrel mathematically generated temperature, and then minus I2, which is the this. I'm not too certain on statistics or math, but this is just how we're told to do it. And I assume smarter people than I know what they're doing. So we're going to Control C. Oh yeah, and then make this easy on yourself. You only have to type this stuff in once, and then for every subsequent thing, because we're going to be like maximum like 12 weeks times 3, so that's going to be a lot of temperature corrections. So make this easy on yourself. Do as much copy and pasting as you can. So like just formulas like this, you can easily just copy and paste it, and that'll make your life a lot easier. Control V. Oops, did it not go? Of course it didn't. Why would it? Oh my gosh. I don't know what's happening. Okay. That was strange. Okay. Control C. Goodness gracious. I don't know. Okay. Control V. Why is it not? Oh my gosh. Of course, this has to happen live. And I'm already 17 minutes in, so I can't. Okay, let me just try copying the cell. Okay, I'm not recording this again for the 3rd time. Great. See how easy that is? Okay, so same thing. Copy the cell, select all the way down, and paste. Control Shift down. We selected everything. Control V to paste. And this is our corrected temperature data. And then we can graph this. Do another line plot. And there we go. Here is the corrected temperature data. Sometimes it looks nice like this. Sometimes it kind of has a weird look. Sometimes there's many blanks in it. That's the blanks are when the sensor didn't record any data. They're technically down here in the negative zone, but we're only doing from 0. And you can also adjust this scale after the fact. From 0 to 100 is probably not the best scale. I think we should do from I think the instructions are from 60 to 120. That'll give us a nice consistent little graph. Anyways, that is the temperature corrections. Now finally we want to find the daily average. Okay, let me bring up I already did one. Cool. So this is the formula for the daily average. It's going to take the average of column J, which is the corrected temps, and we're doing an average if, and we're only taking the average if the value is greater than 0. So all those blanks that got turned into a -100 will not be included in the average. Okay, so copy C. And then copy, Control V, not copy. Cool. Now look, that is our daily average. So this is the average of the entire day. Okay, and that wraps it up for this video. 20 minutes long, wonderful. So yeah, it's kind of a lot the first 1 or 2 times you do it, but once you kind of start doing it, get the hang of it, and you start copying and pasting things, it goes a lot faster. So Hope you all enjoy this and good luck.